Hello everyone, welcome to the very important session, that is Coffee with Concept. In this session, we will discuss very important topic from two subjects, that is network and analog, and that is the integration of two subjects. And that's why it is important for electronics, electrical and instrumentation branch, and it is also important for all competitive exams, whether it is engineering services, whether it is a GATE exam, ISRO, DRDO or BARC. Now, what is the topic then? That is low pass RC circuit, and it is a linear wave shaping circuit. Means I will give you the idea what is the meaning of linear wave shaping, okay, and which are the important topics, as well as you will get the idea about application of low pass RC circuit. Now, I am going to start this session. Then, first of all, this is my introduction. Myself, Sanjay Rathi. I am an ex-IES. I am having around 22 years of teaching experience. I have trained more than 1 lakh students for these competitive exams. And these are my ranks in ESE 2005, 16 and in ESE 2008, 21. Then, this Sunday, we have very important special session for you, that is Learn with Fun. Here, you will get the idea about application of CMIT trigger circuit as on-off controller. Do you want to avoid overflow in case of cooler or in case of overhead tank? Or do you want to avoid complete emptiness of cooler or overhead tank? Then try to use automatic on-off switch. In this session, you will get the idea about all these things and what are the applications of CMIT trigger circuit as a practical comparator. So stay tuned with us. If you are new, then subscribe our channel and like this session. Then guys, first of all, linear wave shaping circuit. What is the meaning of this? Means we are having the two circuit, especially what high pass RC circuit and low pass RC circuit. Remember one thing, suppose we are passing any sinusoidal signal with the differentiator. For example, sine signal with differentiator. So what will be the output cos? Then what about the shape of the sine and what about the shape of the cos? Same, but there is a change in phase only. Remember one thing, when we are passing the same sinusoidal signal with the integrator, again we are getting the cos, but this time again the shape of the output and shape of the input are similar. But suppose you are going to pass non-sinusoidal signal, for example square wave, through integrator, then we are going to get triangular wave, means there is change in shape. So what is the linear wave shaping? The process whereby the shape of non-sinusoidal signal is altered by transmission through a linear network is called linear wave shaping. So that is the simple definition of linear wave shaping. Now, which are the important circuits? First of all, high pass RC circuit. High pass RC circuit, it is also called leading circuit. Second one is low pass RC circuit. It is also called as lagging circuit. Why these two topics are very important? Because if you want to design band pass filter, then high pass filter followed by low pass filter, it is what band pass filter. If you have idea about high pass circuit and low pass RC circuit, then you can design what? Band pass filter. Then if you want to design band reject filter or band stop filter or band elimination filter, then high pass filter connected in parallel with low pass filter and we are adding adder here. So it is what? Band reject filter. So again get the idea about high pass and low pass filter. Then suppose you want to make integrator, then you can design integrator by using low pass RC circuit. Why? Because it is lagging circuit, and for integration we want exact minus 90 degree phase shift. This is a lagging circuit, means we can design the integrator by using low pass RC circuit. Similarly, if you want to design differentiator, differentiator is a leading circuit, exactly 90 degree phase shift. then we can use high pass RC circuit to design what? Differentiator under some conditions. But in this session, we will discuss only low pass RC circuit. Okay. Then what is the low pass RC circuit? Low pass RC circuit means, first of all, get the gain so that you will get the idea how this will work, and second thing, why it is called low pass RC circuit. Gain means what? V0 upon Vi. So this C is replaced by 1 by SC. That is, the impedance of capacitor is 1 by SC. So gain will become V0 by Vi, that is Z2 upon Z1 plus Z2. That is 1 by SC upon R plus 1 by SC, and then finally you will get 1 upon 1 plus SCR. Now you can replace the S by J omega. Then this will become gain 1 upon 1 plus J omega RC. Then in a denominator we are having the omega. Means when omega increases, the gain will reduce. And exactly at omega is equal to 1 by RC, the gain will become 1 by root 2 of maximum. And that's why 1 by RC is called 3 dB cutoff frequency. So here when I am putting the omega is equal to 1 by RC, the gain will become 1 upon 1 plus J1. Find the magnitude of that gain, you will get 1 by root 2. And exactly at omega, the gain, when we are putting the omega is equal to 0, the gain will become 1. The maximum gain of the system. Okay, means when we are increasing the frequency, the gain will reduce, and that's why it is called low pass filter. Means it will pass the low frequency signal, but it will suppress the high frequency signal. Now guys, so that is the gain. First of all, write this formula. You can replace this RC by 1 by omega h, that is called cutoff frequency. Omega can be replaced by 2 pi f, omega h can be replaced by 2 pi fh. 2 pi cancel, this will become 1 upon 1 plus j f by fh. Then if you want to find the magnitude of this gain, you can find the magnitude also. I am giving you the formula for the magnitude, guys. Now watch this. Then what will be the magnitude of the gain? It will become 1 upon root over 1 plus f by fh the whole square. This is the magnitude, right? Exactly at f is equal to 0, what is the maximum gain? 1. At f is equal to fh, it will become 1 by root 2. That is 70%, 70.7% of maximum gain, and that's why it is called 3 dB cutoff frequency. And finally at infinity, the gain will become 0. So that is called frequency response curve. The gain is 1 at this point. Exactly at cutoff frequency, it will become 1 by root 2. Means on y axis we are getting the magnitude of gain, and on x axis we are giving frequency. So this is called frequency response curve. Similarly, when I am talking about the phase will become tan inverse f by fh with negative sign. Why negative sign? Because it is in denominator. So concept of complex number 1, this will become tan inverse of f by fh. This is the phase, guys. Now we have the two curve. This is called frequency response curve. Means, first of all, watch this. This is called pass band. Means up to this frequency it will pass the signal. This is called stop band. Means after cutoff frequency it will try to stop the signal. Okay. In the pass band, the gain is almost constant, independent of the frequency. Here it will start falling, and at this point it will reduce by 3 dB. And that's why it is called 3 dB cutoff frequency. Then this portion is called bandwidth. Bandwidth means the band of frequency for which the gain is almost independent of the frequency, or simply the band of frequency which is passed by the filter. Then that is called what? Phase curve, phase versus frequency. Exactly at omega is equal to 0, the phase is 0. And exactly at omega is equal to fh, the phase will become minus 45 degree. You can correct it, minus 45 degree. And exactly at infinity, the phase will become what? Minus 90 degree. Means every time we are getting the negative phase, it is a lagging circuit. It is a lagging circuit. Then finally, if suppose you are giving the step signal to what RC circuit. So what is the step signal? Step signal means we are having this type of signal. This is the step signal. Exactly 0. It will switch from 0 to V, means for t less than 0 it was 0, and for t greater than 0 it will become V. Suddenly it will rise. Suddenly it will rise. That signal is called what? Step signal. When we are applying the same signal to this RC circuit, then what will be the response? Remember, capacitor does not allow sudden change of voltage. So initial voltage across the capacitor will remain 0. Now the capacitor will start charging and you will get this type of response. Exponentially increasing function, because we are taking the output across the capacitor. Capacitor does not allow sudden change of voltage. So what will be the equation? Here you will get the output as VC, voltage across the capacitor, as V1 minus e raised to power minus t by RC. And exactly at one time constant, that is called tau RC, this will reach up to 0.632 of final value. What is the meaning of the final value? Exactly at t equal to infinite, V0 is equal to Vc will become what? V. This is called final value. And what is the initial value? That is 0. This is what? 0. So now this is a simple RC circuit, that is called low pass RC circuit. Okay, and that is called what? Step response. And in one time constant, it will charge up to around 63.2% of maximum value. Okay, now this is what? Step response. Then guys, why this is very important? If suppose we are simply using the RC circuit like this, R and C, this is called what? Passive filter. This is what? Passive filter. Okay, if suppose the cutoff frequency is what? 1 by RC. Let the cutoff frequency is 1 by 2 pi RC. Okay, but when we are connecting any load, here we are connecting the load. When we are connecting the load, it may be resistive, it may be reactive, it may be capacitor, it may be what? Inductive. Then definitely it will affect this impedance. Z2 is affected because it will come parallel to C. When it will affect Z2, so what about the gain? The gain of the system will change. When the gain of the system will change, definitely cutoff frequency will change, right? Means now it depends upon the load. If the load is variable, then again the problem is very big. Because when the load will vary, the cutoff frequency will vary, the magnitude of the gain will vary, each and every component, each and every parameters of this circuit will vary. Then how we can avoid this? Then we have to design what? Active filters. So what is the active filters? We are using a voltage follower, that is non-inverting operational amplifier, for which the gain is 1 and the phase shift is 0. So this is a voltage follower. What is the gain? 1. And what is the phase shift of this circuit? 0. Most important thing, what is the input resistance up to this point, or input impedance for ideal operational amplifier? It is infinite. When it is infinite, this is R, this is C, and when we are connecting infinite resistance, means it is open circuit. It is open circuit. Now what will happen? This circuit will not affect the cutoff frequency, it will not affect the gain of the system, right? It will not affect the magnitude of gain, it will not affect the phase of the system, because the input resistance is infinite. Now what about the load? We are connecting load here. We are connecting load here. Now because the gain is 1, the same output, for example, the output at this point is V0 dash, then this is similar to that. Why? Because the gain is 1. And what about the phase shift? The phase shift will also remain same, because it will not introduce any phase shift. And that is called what? First order low pass Butterworth filter, and that is the application of voltage follower. So this is the active filter because we are using one active element. Okay, then which type of questions they will ask on this particular diagram? Simply they will ask what is the cutoff frequency. Remember one formula, 1 by 2 pi RC. Right, what about the gain? Directly you can write 1 upon 1 plus j omega RC. Okay, what is the maximum gain? Maximum gain is 1 and so on. Maximum gain is 1. Now, if you want more than that, if you want to increase the gain, then we have to connect what? Non-inverting operational amplifier. What is the non-inverting operational amplifier? You will get the idea by solving this question. So this is a question in GATE exam. Ultimately, we want to solve what? Some questions. So I have given you the concept of RC circuit, low pass RC circuit. Now I am going to solve this question. Remember guys, in coming session, I will give you the idea about the high pass RC circuit. Then we will design what? Band pass filter, band reject filter, as well as integrator and differentiator. Now, in the circuit shown in the given figure, V0 is given by, what is the V0? This V0. First of all, always watch this one, RC circuit. This is a RC circuit. And what about this system? This is a non-inverting operational amplifier. So these two are connected in cascade. When these two are connected in cascade, as you know, for RC circuit, what is the gain of the system? For RC circuit, the gain is 1 upon 1 plus j omega RC. This is the gain for this. This is R, this is C. And what is the omega? Since it is given as sine t, that is nothing but Vm sine of omega t. It is equivalent to, then you can say omega is equal to 1 and Vm is also 1. The maximum amplitude of the signal is 1 volt and omega is also 1. Then you can find the omega RC. What is the omega RC? 1. What is the R? 1 mega ohm, 10 to the power 6. What is the C? 1 microfarad, 10 to the power minus 6, and that will become what? 1. And that's why this gain will become 1 upon 1 plus J1. So what is the magnitude of A1? The magnitude of A1 will become 1 by root 2. And what is the phase shift of the gain will become minus 10 inverse of 1. That is nothing but minus 45 degree. Because it is in denominator. The phase introduced by this circuit is minus 45 degree and the gain is what? 1 upon 1 plus j, that is 1 by root 2. The magnitude is 1 by root 2. Now, what about this portion? This portion is a non-inverting operational amplifier. For non-inverting operational amplifier, the gain is 1 plus RF by R1. So it will become 4.14 divided by 10. That is nothing but 1.414. This is nearly equal to what? Root 2. And what is the phase shift? 0. What is the phase shift? 0, because it is a non-inverting operational amplifier. Now, you can find what is the magnitude of gain? 1 by root 2. And what is the magnitude of gain? Root 2. So 1 by root 2 multiplied with the root 2, what is the magnitude of the gain? It will become 1. Right? Second, what is the phase shift introduced? The phase shift introduced by this is minus 45. Phase shift introduced by the 0. So what is the total phase shift? You have to add minus 45 plus 0. That is what? Minus 45. And that's why if we have any system that has the gain 1, and it will introduce the minus 45 and we are giving the signal sine of t, then the magnitude will multiply here and we have to add the phase here. What is the magnitude? 1. That's why it will remain sine. And what about the phase? Minus 45. So answer is sine t minus 45 here. This which answer is correct? T minus pi by 4, because 45 is written as pi by 4. Now, here this is a MCQ, multiple choice question. One answer is correct. In a seconds we can give the answer. How? What is this circuit? Low pass RC circuit. What about the low pass RC circuit? It is a lagging. Lagging means it has the negative phase shift. What is this circuit? Non-inverting operational amplifier. What is the phase shift introduced by the non-inverting operational amplifier? 0. So what is the overall phase shift? Negative. In which answer the phase shift is negative? Here the phase shift is negative, here the phase shift is positive, here is the phase shift is 0. When the sine is converted into cos, there is a phase shift of 90 degree. Again, it is a positive. Which answer is correct? A. So within 10 seconds, we can give the answer for this question. Otherwise, you can find again, already I have given you the method. You can find the phase shift of the system also. So this type of questions in GATE and other competitive exams. ISRO is coming. In ISRO, they may ask this type of questions. So that is the application of RC circuit. Okay guys, this is all about low pass RC circuit. You are on BYJU'S exam prep. These are our results, right? And these are our toppers. If you want to get the top rank, then simply subscribe our channel, share the link of this session and like the session so that you will get the notification about all coming sessions. Thank you. You are on BYJU'S exam prep. Subscribe the channel. Thank you and good luck for all coming exams.